Welcome back to another wonderful pre-class video. This time we'll be talking about properties of logarithms. So you may recall that there are specific rules that we have to work with when we're dealing with exponentials. Specifically, we have rules that say that any number to the power of 0 is equal to 1. In fact, the only time this is not true is when we have 0 to the power of 0. This is actually undefined. But for any other number, that number to the power of 0 is 1. Similarly, any number to the power of 1 is just that number again. This is true for 0 as well. So, for example, 2 to the 1 is 2, and this is true because we can remember that exponents are just repeated multiplication, and so a single 2 is just 2. If we have two exponents with the same base multiplied together, a to the n times a to the m, then we can just add those exponents, getting a to the n plus m. For example, 2 to the 3 times 2 to the 4 is 2 to the 3 plus 4, which is 2 to the 7. If we break this up into 8 and 16, we can multiply those together and get 128, just as we would expect. That means if we have two exponents with the same base being divided by one another, a to the n divided by a to the m is a to the n minus m. Next, we have a power of an exponent, so a to the n to the power of m is a to the n times m. For example, 2 to the 3 to the power of 4 is just 2 to the 3 times 4, or 2 to the 12. That's 4,096. That also means that 2 to the 4 to the power of 3 is the same thing. And finally, if we have a negative number in our exponent, like a to the negative n, we can write it as 1 over a to the power of n. And similarly, if we already have 1 over a to the negative n, then it goes back to the numerator, and we just get a to the positive n. So with this in mind, we might think that since logarithms and exponents are related, we will have some similar rules for logarithms. Here are a few of them. If we have a logarithm with base a of 1, this equals 0, because remember, we can rewrite exponents as logarithms. This is the same thing as saying a to the 0 equals 1, which you'll remember from the last slide. Similarly, log base a of itself, log base a of a, is always equal to 1, no matter what value of a we have, and that's because we can rewrite this logarithm as an exponent that says a to the 1 equals a. We also have rules for when we're adding or subtracting logarithms, like so. For these rules to work, we have to have the same base in two logarithms that we're adding together. And what we can do is take whatever's inside of the logarithms and multiply them together. As a quick example, log base 2 of 4 plus log base 2 of 3. This would equal log with the same base, and this time we multiply 4 times 3, or log base 2 of 12. Importantly, we can also go the other way as well. If we have two things being multiplied together inside of a logarithm, we can split this up into the sum of two logarithms. This also works with subtraction, but this time if we are subtracting two logarithms with the same base, then we can just divide the stuff inside of the logarithms. And similarly, if we have a logarithm of a quotient, we can split it up into two logarithms and subtract. Finally, this is my favorite theorem. This is called the yeet theorem, because it says if we have a logarithm of an exponent, then we can take that exponent and yeet it to the front and this will turn an exponent into a multiplication problem. It also works the other way. If we have some number being multiplied by a logarithm, we can yeet it inside of the exponent, and it becomes a log of an exponent. Anyway, this is called the yeet theorem, and hopefully you'll now never forget it. Finally, if we have a logarithm that is negative, we can bring that negative sign inside of the logarithm. This is actually an application of the yeet theorem, where this negative sign is the same thing as a -1. And so we could write this as log base a of n to the -1, which is, of course, log base a of 1 over n, using our rules of exponents. In class, we will practice identifying the rules of logarithms. We'll do some problems where we're expanding logarithmic expressions using these rules, but also condensing logarithmic expressions using the rules, because they work both ways. And finally, we'll talk about how to evaluate log expressions without a calculator. See you there.